Gauss Suedal method. So it is an iterative method in numerical computing to solve system of linear equations. Consider a system of linear equation. System of as now. For this Gauss Seidel method, we first have to check whether the given system of linear equations are diagonally dominant or not. It means for the first one, it modulo coefficient of x, that is a1, must be greater than. Similarly, for the second linear equation, this value must be the larger, that is greater than. For this equation, this value must be larger, that is. Let us see an example. For an example, here we have to check first whether it is diagonally dominant or not. That is, so in first case, here 3 is greater than 1 plus 1, so it is diagonally dominant. In second case, 4 is greater than 2 plus 1, 3, it is also diagonally dominant. And in third case, 6 is greater than 3 plus 1, 4. Yes, all these equations are diagonally dominant, so we can proceed this in the same way. But if sometimes the question is given as so, here we have to see these three values is not greater than this plus this, and this one modulus of 1 is not greater than modulus of 3 plus modulus of 6, and in this case modulus of 1 is not greater than modulus of 3 plus modulus of 1. So what we have to do is, now where the coefficient of x is dominant, it must be placed first. That is, in this third one equation, x is diagonally dominant, so we will place it in the first. Now where the coefficient of y is dominant, we will place it at the second. Here this one equation, and finally the remaining one. So here 3 is the highest among these two values. Here 4 is highest among these two values, and 6 is highest among these two values. So this is diagonally dominant, so we can proceed for this. After the idea for diagonally dominance, we will now solve for the equations. So first of all, given equation is 3x plus y plus z equals 8, 2x plus 4y plus z equals 9, and 3x plus y plus 6z equals 13. From this first equation, we will separate x, that is x equals 8 minus y minus z by 3. From this second equation, we will separate y, that is y equals 9 minus twice of x minus z by 4. And from this third equation, we will separate z. That is, z equals 13 minus 3x minus y by 6. Now let x equals 0, y equals 0 and z equals 0 be the initial guesses. So value of x at 0 equals 0, y at 0 equals 0, z at 0 equals 0. Now we will use this first stage value 0, 0, 0 in these above equations x, y, z to obtain the values for the corresponding iterations. That is x1, y1, z1. Okay, here we have 8 minus y0 is 0 minus z0 is 0 by 3 equals 8 by 3. Now for this, now again we have to use this 9 minus twice of this 8 by 3. 8 by 3 minus and z is still 0 by 4. We will get here 11 by 12. Now for z we have 13 minus 3 times x is here 8 by 3 minus y is here 11 by 12 by 6. We will get here 49 by 72. Now we have to proceed similarly for x2, y2, z2, x3, y3, z3. So that becomes little time consuming. So we will make some set of equation from here and use it into the calculator and obtain the corresponding iterations easily. So let us make the equations from here. That is a equals 1 by 3 8 minus b minus c, and we will use this type of symbol, colon type symbol, and b equals 1 by 4 9 minus twice of a minus c. Again we will use the same symbol. C equals 1 by 6 13 minus thrice of a minus b, but at this time we don't use the symbol here. Okay, and we will directly press the calc key. So first reset the calculator, shift 9 3. We will set the calculator for ready mode and we will make the use of these equations in calculator. Alpha equals 1 by 3 8 minus alpha b minus alpha c, and alpha and this one symbol alpha equals 1 by 4 9 minus twice of alpha a minus alpha c, and again this one symbol alpha equals 1 by 6 13 minus thrice of alpha a minus alpha b. Now we will get the values for x, y and z in terms of a, b and c. Now we will press this calc key and for b we will give the value as 0, for c we will give the value as 0. Now y at 8 equals 0.99999840 and z at 8 equals 1.00004771 for x9, y9 and z9. Okay, we have the values as 1.99999894, 0.999934, 1.000000. Now for x10, y10, z10, we simply press this equals to key, x10, y at 10 and z at 10. We have to observe the values. The values is almost accurate here. So x at 10 equals 2.0000, y at 10 equals 0.99999 and z at 10 equals 1.00000. For the next iteration, x at 11 equals 2.00000, y at 11 equals 0.9999970, z at 11 equals 0.999999814, x at 12, y 12 and z 12 equals 2.0000016, 0.9999999, and for C 0.9999 0.99999, and for x13 we get x at 13, x13, y13 and z13 values. x13 is 2.0000000 and y13 equals to 1 and z13 is equals to 0.99999. So again, for the next iteration, we get the values at a equals, that is x at 14 equals 2.00000, y at 14 equals, here it is 1, and z at 14 equals, we get here again 0. For x at 15 2 1 and again 1. So the final value at is obtained at x15, y15 and z15 as 2 1 1. So let us put the value in the above equation, whether we are getting the same equation or not. So let us check. 3 into 2 plus 1 plus 1 equals, if this is right, 2 into 2 plus 4 into 1 plus 1 equals nice, this is also right, and 3 times of 2 plus 1 plus 6 times of 1, 6 plus 6 12 plus 1 13. So our values 2 1 1 are correct. This is the method using Gauss Suedal iteration for obtaining the values for the given set of equations. Thank you.